right, so section 2-4, solving equations graphically. So what we're looking at here, and it's very important to remember this because it makes a difference in your answer. If I have this equation, x squared minus 2 equals the absolute value of x plus 4. That equation can be solved algebraically, but it is rather difficult to do so. So when we have multiple nonlinear equations, we can solve them by separating them into two separate equations and solving them graphically. But our answer, and this is very important, should only be x values because we only start with x. So that's something to remember. If you're starting with x's and y's, your answer should have x's and y's. If your original problem starts with only x's, you should only end with x's. So make sure you keep that in mind. Always look with what you start with and what you end with. So the way we're going to do this, turn the light on for that. We have x squared minus 2 equals the absolute value of x plus 4. So I'm going to separate that into two equations. So x squared minus 2, absolute value of x plus 4. And this is where it's important that you're comfortable with those graph transformations. So this x squared minus 2, what is that shape going to look like? A parabola, and what's going to be different about it? It's just going to be moved down twice. So our normal parabola has a vertex of 0, 0. This is going to be moved down to 0, negative 2. And it has the same pattern, and this is where, as well, graphing precisely is important. So we're going to go out 1 and up 1 in both directions, out 1 and up 3, out 1 and up 5, and then we just graph this the best that we can, as precisely as possible. Okay. So then the next one, what is that, this absolute value of x plus 4, what is that one going to look like? Yeah, it's going to be the absolute value, which looks like a V, moved up 4. So with the absolute value, because I have no stretch factor on it, no, the A is not any different, and it's not being moved left or right, then I'm just going to go out 1 and up 1 in both directions continually. So I have my points of intersection here and here. So with a system of equations, I would write those 2 points down, but I only have an equation to start with. So what do you suppose I'm writing down here for my answer? Only the x values. So I only care if this is the point 3, 7, and this is the point negative 3, 7. The only thing I care about are what x equals. So it's only going to be my negative 3 and positive 3. So x equals negative 3 and x equals positive 3. So on the next one, we have the square root of x plus 1 minus 2. That means we take our normal square root that starts at 0, 0, and we move it left 1 because of the plus 1, and then down 2 because of the minus 2. So our HK is negative 1, negative 2. And if we turn this sideways for a moment, remember that the square root takes on the same form as the parabola does, the same pattern. So the out 1 and up 1, out 1 and up 3, out 1 and up 5. Questions on the square root part? All right. So then the line has the y-intercept of 1 and a slope of negative 1/3. So we start our line at 1 and we go down 1 and right 3, down 1 and right 3. So we have a point of intersection right here at 3, 0, which means our solution is x equals 3. So we didn't start with any y's, we don't finish with any y's. It. So instead of the 2 being on top, it's out in front, and our a is 2. So we're going to move forward with this example, even though we don't, for your test, I'm not going to give you a hyperbola that's been transformed with a different a. But what do we know our asymptotes are going to be on that hyperbola? Where are our asymptotes?
3.
X equals 2. So I'm going to do this one in. And y equals negative 3. So a normal hyperbola is going to go from your point of intersection out 1 and up 1, because our normal one is y equals 1 over x. So if I put 1 in here, I'm going to get 1 for y. Now, if I have a 2 in front of that, and I put in 1 for x, then I'm going to get 2 for y. So I'm going to use that same pattern in both directions according to where my asymptotes are. So the same kind of thing here. If I go over 2 and I put 2 in for x, I'm going to get 2 over 2, which is 1. So my points that I'm using are just out a little bit from there. As I mentioned before, I'm not going to do this kind of transformation on a test, but still good to know. And hopefully our graph is going through one of those points, because otherwise... Okay. Yes, it does. So, that's the graph of my hyperbola, which I guess I can put that here. And then my other one, x minus 6, what form is that taking? X minus 6 is what kind of graph? A line. Where does that line start? Stop talking. Negative 6. And from negative 6, where do I go? Up 1 and over 1. Whoops. Sorry. The hyperbola one is a little bit confusing. So anything on your parent graph toolkit is fair game. So I might use a hyperbola, but I will not change the A for your test on a hyperbola. I would with any other graph, but not the hyperbola. Yeah, it would just be, if you had a hyperbola on your test, the A would just be 1. Might be negative 1 where it gets flipped over, but nothing other than 1. So, I'm crossing my graph here and here. So this is the point 1, negative 5, and this is the point 4, negative 2. So what are my solutions then? 4 and 1, just my x values. So for this point, let me highlight those. This point right here, and this point right here. So my x's equal 4 and 1. And if I wanted to check my solutions, what would I do? If you don't have a calculator, because you won't have a calculator on this part of the test. Asha, say that again. Plug it in for x. So if I put 2 over 4 minus 2 minus 3 equals 4 minus 6, so I'm checking the 4 right now. I have 2 over 2 minus 3 equals 4 minus 6. 2 over 2 is, whoops, that's a 3. 2 minus 2 is 1. 1 minus 3 is negative 2. 4 minus 6 is negative 2. So I know my solution for 4 is correct. Will. I am teaching. Stop talking. Michael, go back to your desk. On the other one, check with 1. So I've got 2 over 1 minus 2 minus 3 equals 1 minus 6. So this is 2 over negative 1 minus 3. I'm going to bring that over here. Negative 2 minus 3 equals 1 minus 6. So negative 5 equals negative 5. So I know I've graphed both of those correctly.